Hey guys, welcome to Let's Talk Algorithms. My name is Venkatesh and today we'll be solving the problem Remove Invalid Parentheses. Let's look at the problem description. Remove the minimum number of invalid parentheses in order to make the input string valid. Return all possible results. So the input is basically a given string which has, let's start a workbook. So you have a string like this and the question is asking to basically remove the number of invalid parentheses in order to make the input string valid. So if you have seen the earlier question in Leetcode, which basically asks for whether a given string has valid parentheses or not. What do you mean by valid parentheses? Let's do like a very quick review. So if you have equal number of open and closing brackets in the right order, then it's valid. If it is, let's say you have one left parenthesis and two right parentheses, this is invalid. So you just basically need to have the valid number of left and right parentheses in order. So now the question is asking, given a string like this, remove the minimum number of invalid parentheses. So we try to remove the minimum number of parentheses and generate all kinds of valid parentheses combinations. So first thing, when it says remove the invalid minimum number of invalid parentheses, so ideally whatever the number of parentheses left or right, which is basically invalidating the string, only those things we have to remove. So look at this string. If you look at this, the first left parenthesis has a matching right parenthesis. That's nice. The next left parenthesis has a matching right parenthesis. Again, great. But you see again here, there is a right parenthesis without a matching left parenthesis. So this is already invalid after at this part basically. So what happens? So let's take this example. So sorry about that. All right, you got this string. So you can get valid parentheses by removing that part, right? That is one valid combination. What else can you do? So we know there is basically extra one right parenthesis. So you can remove that, or you can remove this. So what happens if you remove this? So there is a left parenthesis, and a right parenthesis, and a right parenthesis. Basically, when you say valid parenthesis, the last opened left parenthesis should have a matching right parenthesis. That is the crux of the valid parenthesis validation. So you have two combinations now, and as you see, the question is asking for given an input like this, and you need an output like this. So what did we do? So we found out the first matching parenthesis, which is invalidating the current string, and then we removed that character, and then we generated the valid parenthesis string. That's nice. So what else? Basically, again, as I said, there is one extra right parenthesis, but I mean, is it the only place you can remove and make it a valid parenthesis? Not necessarily. See, when we remove this parenthesis, and the rest of the string is still valid. So again, going back to how do you check whether a given parenthesis is valid or not? You can check it multiple ways. The simplest way is every time you see a left parenthesis, basically you increment the count of a counter. Let's say we have a stack. Every time you see left parenthesis, you see stack plus plus. Every time you see right parenthesis, you do stack minus minus. So at the end, at any point, if stack is basically less than 0, then we have an invalid parenthesis. This is a way to detect basically whether a string is valid or not, has valid parenthesis or not. So the brute force approach is basically remove every character in the string, and pass it on to a valid parentheses function. See if it is valid. If it is valid, then you add it to a a set. Set because we want a unique combination of strings. So that is a brute force approach. Let's write it down. So brute force is remove every character, check if it's valid, add it to the result. So what can we improve on this? Naive improvement is find out the extra number of left and right parentheses count and remove that many from the given string, check if it's valid or not. This is already a great improvement, right? So you are not removing any random character. Instead, you are removing the extra number of left and right parentheses. So the better way to do is like optimize version. So instead of, so when I say remove the extra number of left and right parentheses, if you can see here, there are two right parentheses here, right? So here we detected that there is an extra parenthesis. So you could remove this character and you could remove this character. But what happens if when you remove a consecutive right parenthesis characters which are together is you basically get to the same result. So you either have to use a set or some kind of hash map, like in Golang we don't have a set, to track the unique number of possible results. So to avoid that, we can just basically have a condition saying whenever you are trying to remove a character, check if the previous character is already not, right parenthesis. If you do that, it basically already provides the solution that you don't have to dupe check, duplicate check the results. So the optimized version is find extra left parentheses. Let's say we start with the right parenthesis. Remove non-consecutive character, check if it is valid, add it to the result. So another extra improvement is, so we are doing the right parentheses. What about left parentheses, right? So instead of having custom logic designed to do the same thing, you could just reverse the string, and check for extra left parentheses. So this gives the optimized result we are looking for. What do we do? Let's comment all these things out and let's start coding. So we need a result, a string of arrays, sorry, an array of strings. All right. So we initialized a string array. What are we going to do? We need a helper function. So what does this helper function do? Takes a string, takes the result, and then you have two indexes. You have a start and you have last removed index, which is basically int, and then you have a pair of byte. Byte is basically character here. So what do we make the initial call with? Remove of pass the initial string as and a reference to the result string, and then 0 0, and then the pair is basically nothing but the parentheses combination. Initially you start with left parentheses, right parentheses, and then once assuming the helper function does all the stuff for us and generates a result, you return the result. So first things first, what do? Let's have a stack, a variable stack, and index I is equal to, so stack starts at 0 and I starts at start, and I is less than length of s I plus plus. Whatever the strategy we discussed here, what we are going to do is we do that recursively here. So let's say now you start with this string, right? So if s of I is equal to pair of 0, then stack plus plus can just basically do the same thing. If it is 1, then do stack minus minus, right? So basically left parenthesis increase the stack value, right parenthesis decrease it. If the stack value is greater than or equal to 0, then basically continue. We don't have to do anything. We have valid parentheses here. So that is how you check, mid calculation, that whether a string is valid or not. Now, if this is not, if that doesn't hit continue, basically then we have a invalid parenthesis. What are we going to do about it? Let's say you have a for loop which starts at last removed index and j less than or equal to I, j plus plus. I will explain why we are doing this in detail in a minute. S of I, sorry, if s of j is equal to pair of 1. So pair of 1, an extra, and j is equal to last removed index, or s of j minus 1 not equal to pair of 1. If this is the case, then you call recursively. You basically remove the current character, which is right parenthesis, and then return the rest of the string and pass the result I, j, and then pair, and we return here. So this part is obvious, right? You start with this string, and then let me explain this here. So you start with this string, you start with 0 0, you check the string of I is 0 is equal to pair of 0. Pair of 0 is opening character, so that is true. We increment the stack, and then we check if stack is greater than or equal to 0. That is right, so we continue. Again, we skip the rest of the for loop. So we are at I equal to 1 now. You check I equal to 1 equal to the closing parenthesis. You decrement the stack. So stack is still greater than or equal to 0. You continue. So you continue until here, until when you hit I equal to 4, basically, right? Oh, 1, 2, 3, 4. When I equal to 4 index, you check what you do. You compare if it's a right parenthesis, yes, and do decrement the stack. At this point, stack is 0. So now we are decrementing, so stack will be minus 1. Stack is minus 1. Excuse me. So stack is minus 1. What are we going to do when stack is minus 1? So we start at j equal to the last removed index. So initially we are passing 0. So j starts at 0, and j is greater than j is less than or equal to I. I is 4. So we are looking at j. Just want to put them side by side. I 4. So at this point, j is 0 and I is 4. So we are basically looking at this part of the string. Let me take that part of the string. So yeah, this is the part of the string we are looking at. Now we start at j equal to 0. Check if j is right parenthesis. It's not, so increment the count. Check if j is right parenthesis again. Yes, it is. And then check if j is the last removed index, which is 0. So j is not 0 now because j is 1. And or basically if the previous character, which is j minus 1. So just to be clear, stack is still minus 1. This is 1 and this is 4. So check if j minus 1, which is 0, is not equal to closing braces. So as I said earlier, one way to avoid duplication in result is basically don't consider consecutive right parentheses. So since the j minus 1, which is 0, value is not right parenthesis, we come inside. What are we going to do? We remove the character now. So we remove this character. So let's see, what are we generating here? We remove this character and append it to the rest of the string basically. So rest of the string would be like this. So we are sending this string recursively to this call. So what happens is when you pass this string, this is a valid parenthesis. So stack would be never less than 0. So we will basically add this to the result. So let's say we did all this and it recursively did the job of validating whether it's a valid parenthesis or not. What are we going to do? Let's say, so I wrote a little helper function basically to reverse a string. Golang doesn't have it, so we have to write it ourselves. So why are we reversing the string? Because we want to reuse the code for the same left parenthesis. We are doing it for right parenthesis, so we want to reuse the code for left parenthesis. Instead of like writing custom logic again, you could just reverse the string and pass it on. So if pair of 0 equal to a left parenthesis, then this is basically a valid right to left approach, but we want to reverse it. So remove of s, comma, result, and you start with 0 again because this is a new string, and byte of. So what are we going to do? Instead of passing left parentheses and right parentheses, we'll pass right parentheses and left parentheses. All right. So we do that, and if this is not right to left, then we basically, this is a left to right approach. Then we should basically finally add the value to the result. All right, S. So since we are using a pointer to the array, we don't have to return it. Ideally this should work. Let's check. All right, it ran and it gave the valid output. So if you're interested in how the string S is changing, you could just do a print. The better approach is apparently putting this out on a paper and then doing a traversal how it works. But for us to just see how the string is changing, so this is the std out. As you can see, this is the initial string we are passing, and then this is the value I said we are passing. This is the first time we are passing this. So next we are passing some invalid string, basically reversing it. It's not valid. So the other thing is the second approach, removing a later part of the right parenthesis. So finally we end up adding only the valid parenthesis, right? All right. So let's submit this. All right, this is accepted. Runs in 4 milliseconds. If you have any questions, please feel free to add a comment. And if you like the video, please subscribe and like the video. It gives me motivation to probably like do more videos. Thank you.